Section 8.2 Partial Derivatives. In this section, we are going to find partial derivatives of functions of two variables and find the second order partial derivatives. For the first order partial derivative, consider the function of two variables as z equals the function of x and y. X and y are independent variables and z is dependent variable. We find the derivative with respect to x by temporarily treating y as a constant and a derivative with respect to y by temporarily treating x as a constant. The partial derivative of f with respect to x is, if it exists, by the definition of the limit. The partial derivative of f with respect to x with this notation is similar to the derivative of the function of one variable that we use as, for example, y equals f of x. When you find the derivative of the y prime or the f prime of x, another notation will be in the form of dy by dx. But for the case of the function of the two variables, it's similar to the dy by dx, but the where you write the d is kind of curvy back to the front. Instead of the straight back d, you're going to make it curvy to the front like that. So partial f with respect to x by the definition is the limit of the function of x plus h y minus f of x y all divided by h. As you notice, the chain will be with respect to x only, while the y variable does not change. And similarly to the partial derivative of the f with respect to y, the chain will be with the y variable, where x doesn't change at all. The following notations are also used to indicate partial derivatives. The partial f with respect to x, where f as a z, or the notation z, we can write it as partial z with respect to x, or the shorter version as the f as a function and the subscript x to indicate that this is a function with the derivative of the function with respect to x. Or this is the shortest version as f subscript x. Same as the partial derivative of the function f with respect to y. You can write as the partial z with respect to y or the f subscript y. When you find the value of the partial derivative of the z as a function of the xy with respect to x at the point, so this is the function of two variables. X and y are independent variable, and z or the f is the dependent variable. So we're gonna have the coordinates at x comma y comma z, where z is the f or the function where x and y are independent variable. So when you evaluate the value of the partial derivative, you're gonna find the partial derivative first and then replace x and y value into the derivative that you derive. Let's take a look at the example. For number one, consider the function and then find the partial derivative with respect to x and the partial derivative with respect to y. In part A, f of xy equals x squared times y plus 4 times x times y to the third plus 6. First of all, when you find the partial derivative with respect to x, or the short term as f subscript x, you're going to find the derivative of the function with respect to x only, where the y will be treated as the constant term. So I'm going to write in this form. As you have three terms, we're going to do the derivative 3 times. For the first one, if we see the y as the constant, so we can look at just the x term. The second term is the same thing. We're going to look at the x here. That means for the first one, we find the derivative where y is just the constant, or we treat it as a constant multiple. Derivative of x squared is 2x. And the second term, where y to the third is treated as a constant, the same as 4. The derivative of the x is 1. And the last term, the derivative of the constant 6 is 0. So I'm going to highlight the derivative in yellow, the same as the piece that we treated as the variable for the partial derivative with respect to x. Therefore, the partial derivative with respect to x is 2xy plus 4 times y to the third for part A. And then for the partial derivative with respect to y, or f subscript y, is the partial derivative of the function. We treat y as a variable where x is a constant. I'm going to highlight in different color to make it different. So treat y, so we focus on the y term here. Then the partial derivative with respect to y, where x squared is treated as a constant. Derivative of the y is 1 plus 4x as a constant. Derivative of y to the third is 3y to the second. And the derivative of the 6, which is constant, is 0. In this case, so I'm going to highlight again the derivative that we did in the same color as the original term y. That means the partial derivative with respect to y for part A is x squared plus 4 times 3, that's 12, x y to the second. And write in the notation f subscript y.